everybody, and I want to begin by thanking the two Anthonys for the invitation to speak here today. And I'm going to speak briefly about some research that I was involved in, both my PhD research and some other research in relation to vision impaired and blind students. And I suppose I'm particularly looking at primary and post-primary. I now realise my dog has vanished, but that's fine. So I'm going to speak very briefly about it, and I suppose to begin with, blindness and vision impairment is a low incidence disability, so it wouldn't be particularly common within many mainstream classrooms. And I suppose it's important to realise that those with vision impairment have the same curriculum needs as all students. However, because of their vision impairment, their challenges can be exacerbated by their vision impairment because of the nature of how, particularly when we use traditional forms of teaching and learning. And within Ireland, those that are blind and vision impaired have been included in mainstream classrooms with a number of decades now. However, the system hasn't always changed to meet their needs. And I suppose just to make a distinction between vision impairment and blindness, those that are vision impaired often work through the medium of print. Now, they magnify it, and some of the earlier speakers here today identified some of the challenges there, and I'll come back to some of them. But they often work through the medium of print, while those that are educationally blind cannot work through the medium of print, so will either work through braille or with assistive technology. And just to say, many of those that are classified as blind have some vision. It may be just light perception and things like that, but it's a very small cohort that have absolutely no sight at all. I suppose in relation to maths and things like that, it's really important to realise that font style can make a big difference in relation to how legible maths can be. And I suppose something very simple, even to think about, the different signs that are used in maths. If you have a vision impairment, so if you're using your sight to read, because we'll just say the addition and the division signs, while somebody that has good sight, can identify them quite easily, somebody with poor vision can misread them, and therefore it appears as if they don't know how to do a maths problem, but actually the problem is that they have misread the sign. So I suppose it's just important to recognise those sort of things as well. I suppose when you think about maths as well, maths is often taught in a very visual way. It's two-dimensional, it's non-linear, and when you, and I'll show you a small example in a minute, in braille, that is very difficult to replicate. So often it's identified that braille on its own isn't always enough to facilitate the learning of mathematics. And I suppose one of the problems with braille there as well is that many maths teachers, and I'm not singling out maths teachers because many teachers in mainstream schools do not know braille, but particularly when it comes to maths notation, they don't recognise that it's very different from how it's represented in print, and that can cause issues. I suppose those that use speech synthesizers or screen readers, as was mentioned earlier, again, not all screen readers read maths in a coherent and beneficial way. I suppose one of the things that we need to realise is that a lot of learning particularly in young children, happens through the medium of what they see around them. So it's constantly being reinforced through what they're seeing around them, whereas vision impaired and blind children do not always have that available to them, so their concept development can be impacted by that. If I ask people here what shape is a ball, what would people generally say? So I suppose concept development, most of you here would have said probably round or spherical for the shape of a ball, but then what shape is a rugby ball? Oval, okay? But how do you know that? And it's probably because you've seen one. Like if I ask people what colour is the sky, it depends on, what the weather is like. But if you don't see it all, you don't know that unless somebody really explains it to you. So I suppose this is why I'm saying maths can be very challenging, and there's a lot of assumptions, when in relation to doing maths, there's a lot of general knowledge expected and assumed that you may already know, and if you have very little sight or no sight, then that can be challenging. Some of the challenges, for those who participated in my research was that, they had Braille books available to them, those that needed work through the medium of Braille, but none of the diagrams were replicated in the books. So they were missing out on a lot of significant information in relation to that. And then often when it came to doing exams, particularly at state level exams, because they used Braille, but they were expected to produce their exams in printed format. They were doing it on computers, but they didn't have the knowledge that Emma was talking about how to do the mathematics on a computer. So one of my participants called Joe, he made up his own mathematical notation. So for x squared, he put xx. Now, as he said himself, it was probably a huge challenge for the person working on correcting his exam paper. But if he didn't have a choice. Now, he did get some supports when it came to the Leaving Cert, but again, and he strongly said he felt sorry for the school because he felt they had not been given the necessary supports to accommodate him and to support his mathematical needs. I suppose another thing is that, until this year, I think, or last year, is the first year that the State Examinations Committee have agreed to pilot a programme whereby those that generally use electronic formats to access their curriculum can actually now receive electronic versions of their mathematics paper. So those that may be using print, they were able to get it in Braille, but they weren't able to get it electronically. So somebody who was needed it magnified. I read about a case last year whereby a student about to sit their Leaving Cert who was doing honours maths, in order to read it at a comfortable level for him, if it wasn't in electronic format, it would run to 54 pages, one paper for his Leaving Cert exam. Now that's unrealistic, really. So it's those sort of challenges they often face. So between, the lack of awareness around Braille and, not being able to access maths in the format that you desire, it causes significant issues. And I suppose the big problem then is really maths is seen as so essential to go on to third level education, and they're being impacted. Like Joe, who did honours leaving cert maths, who is totally blind, was actually advised to give up maths altogether and to not do it for his leaving cert. He was concerned at the time that he may want to go on and do computer programming and refused to give up the subject, and ended up getting a D1, but he was really disappointed because his lowest other results were A2. So it just shows the challenges that those that are vision impaired and blind encounter when trying to do the maths curriculum. And I'm there. I don't know if you can see this or not, but I suppose this is just to replicate or to show in a very bad way, I suppose, really, how print mathematical problem is represented in braille. So the print is on the left-hand side as I'm looking at the screen. The formula or the maths problem in braille is on the right-hand side of the screen. You can see it's very differently laid out. So thank you very much for listening to me today.